In this video, we will learn how to easily identify Wittig reaction and how to predict the product of a Wittig reaction. So in order for Wittig reaction to happen, we must start with a ketone or an aldehyde, which is when we have a C double bond O either in between two carbons, that would be a ketone, or in between a carbon and a hydrogen, that would be an aldehyde. Next, our Wittig reagent is very memorable because it has a phosphorus here. So our Wittig reagent is C6H5 three benzene ring connected to phosphorus with some sort of carbon chain or alkyl group connected to this phosphorus. So I just put negative charge on the carbon next to R. My R could be any kind of hydrocarbon chain. Now, this Wittig reagent can be written differently. Sometimes professors write plus on phosphorus, minus on the carbon. Another way to write it would be to put a double bond in between phosphorus and carbon. And then another way is instead of C6H5, a lot of times it's abbreviated as PH, which is phenyl, which is the same as benzene ring. So there are a couple of slightly different ways to write this reagent. And notice that Wittig reagent will have phosphorus with 3 benzene rings, but this part could be different based on the reagent. So how do we predict the product of a Wittig reaction? All we have to do is we will have to look at this carbonyl carbon, the C double bond O, and we will have to replace the oxygen with this part of the Wittig reagent, the part that has the carbon and whatever is connected to that carbon. So we take oxygen and we replace it with the carbon and whatever is connected to the carbon from the Wittig reagent. I wrote here an easy way. I wrote replace oxygen with CHR to create an alkene from a ketone or aldehyde. So what the Wittig reagent accomplishes, what this reaction does, is it turns your ketone or aldehyde into an alkene. So for synthesis problems, if we start with a ketone or aldehyde and we see that in the product we see a double bond C double bond C, we see an alkene, then we know it's probably a Wittig reaction was probably used in the synthesis. Now let's go ahead and predict the product and read this kind of problem. So it says here, what is the product of the reaction below? And we see that here we have a ketone, we have a C double bond O in between two carbons. And we also notice that we have a Wittig reagent. In this case, we have C6H53P plus with CH2 minus, and the solvent is DMSO. We don't really care about solvent as much. The most important part is this part. And what I will do is I will do what I wrote in my prototype. So I'm going to rewrite my molecule, and this carbon was the carbon that was connected to a double bond O. And I'm going to replace the double bond O here with the half of that Wittig reagent, the half that does not have the phosphorus, so this half. So this is the carbon, and this carbon is actually just attached to 2 hydrogens, so that's all we will have to do. We will just have to attach this carbon to 2 hydrogens, and that is my product. So all I did is I replaced my oxygen, in this case with CH2. Now, if that carbon had other groups connected to it, those would be my connections in the product, but it just has 2 hydrogens, so I just drew 2 hydrogens here. Now, all we have to do is to name this molecule properly in order to get the correct answer choice here. So another way to draw it is to just draw it like this, and now it will be easier for me to name it. To name this molecule, I see a double bond, so I'm going to find the longest chain that includes the double bond, and I will name it from the end closest to the double bond. So the longest chain that includes the double bond is this, 1, 2, 3, 4, 5, and I'm going to number it the same way so that my double bond has the lowest number. And so I must have pentene, so I can get rid of this because 5 has the prefix pent, and then I see a double bond, so it must be pentene. I have one pentene because my double bond is on the first carbon. So I have one pentene for all of them. And then I also notice this substituent here, which is a methyl group because it's just it's just a CH3, which is a methyl, and it is on the second carbon. So my full name should be 2-methyl 1-pentene, because I see that I have a methyl group on the second carbon and my double bond starts from the first carbon and my parent chain has 5 carbons. So 2-methyl 1-pentene should be A. This is Maya from Transformation Tutoring. I really hope that you found this video helpful, and I look forward to seeing you in more of my organic chemistry and general chemistry videos.